Hey everyone, Johnny here and welcome to another video. Today I'm going to be taking you through 5 different types of quadratics that you may be faced with and that you may be required to factorize and eventually solve in order to find the x-intercepts on the particular graph that you're dealing with. So I've got 5 different types of quadratics here that I'm going to be going through because I feel like these are the primary types that you could actually be asked to solve or be asked to graph, in which case you need to know how to actually go through the process of factorizing them or solving them when you make y equals 0 in order to find the x-intercepts on a graph. So I'll explain all of this in this video and we'll go through each one step by step. But before I do that, if you haven't already, please subscribe to the channel and click the bell. Do that now for me if you can. And if you enjoy the video, like and comment. Okay, so let's get into our first example. So the first type of quadratic you can get, and notice that all of these are quadratics because they are x squared, they have x squared in them. If you can see, all 5 have x squared in them. Not only do they have x squared in them, but there is no term in any of them where there is a power above the x that is greater than 2. And that's really important because a quadratic is a type of function. It is a type of function where you have y equals something with x squared where there is no x cubed. There is no x to the 4. There is just x squared and then potentially a term with just x. So not even x squared on this one. And then you may also have a constant, that is a number by itself, positive or negative, without an x. So you can have up to 3 types of terms in a quadratic, with the biggest power on x being 2. Now when you draw a quadratic, just as a preliminary point here, you are either going to be getting a parabola that is upward facing, so it's like a normal U shape, or you're going to get an upside down U shape. It's one or the other. It will be a normal U shape when the number in front of x squared is positive. So if you have a positive 1, an invisible 1, like in the first case, when you draw the graph of y equals x squared, it is going to be a normal U shape. But if I had negative in front of the x squared term, such as negative 4x squared, then you are going to get this upside down U shape. But both of these are called parabolas, and that is the name of the shape, right? That is the shape of the curve, okay, that you'll get when you do a quadratic. So when you do a quadratic and you draw it onto a graph, if you draw it onto a graph, the shape of the curve that results is called a parabola. Okay, so now we've talked a little bit about why these are all quadratics and what it would basically look like if you were to graph it, or any of them. Let's have a look at the first one. So the first example is y equals x squared. Now if we want to solve this, if we want to find the x-intercepts of this graph, so if I was to quickly draw an x-axis, a y-axis, and a 0, if I wanted to actually graph this and find the x-intercepts, which means, and this is the x-intercept, right? If I want to find the x-intercepts, which are the points at which the curve goes through the x-axis. Now the x-axis is this horizontal line here, right? It is this horizontal line here where I'm drawing in green. That's the x-axis. The x-intercept is not the axis, but it's the point where the curve or the parabola that we're going to draw will cut through it. Okay, it will cut through it at a certain point. Now, I already know what it's kind of going to look like, so I'll just draw it on. But let's go through the process of finding exactly where this curve will hit this green line. Okay, the way you do that, the way you find any x-intercept is to sub y equals 0. So we can make 0 equal x squared. Great, we've got 0 equals x squared. Now we need to solve that. Okay, and I like to rearrange this. I'm just flipping the sides. You can always do that. X squared equals 0. How am I going to find x? Well, what's the opposite of x squared? Because you want to use inverse equations, inverse operations, I should say, to solve an equation. We need to find what value of x is going to make the left side equal the right side. That's what solving an equation means. So because we're finding the x-intercepts, we made y equals 0 because that will tell us where the x-intercept is, because it always happens when y is 0. Because we have that, we're left with an equation, and then we therefore need to find what value of x, what number can we put where x is, so we get rid of x and we put a number there instead. What number can we put in there so that both sides will equal each other, which means you've solved the equation, which means you now know where the x-intercept is? Well, you do the opposite of what's happening in this case. So this is where you just have the 1x² term by itself and nothing else. So what we do is we square root both sides, because to get x by itself, you need to ask yourself, what's stopping x from being by itself? And at the moment, the thing that's stopping you from having x by itself, so that you can see what the answer is the squared. So you do the opposite of squared, which is to square root. And then the golden rule comes into play, which is what you do to one side, you do to the other side. So now we have to square root the other side. And importantly here, you have to note that whenever you square root a number, even if it's 0, you always have to put a plus minus before the square root. Okay, because the negative of a number, when you square it, think about negative 2. Negative 2 times negative 2 is positive 4. Positive 2 times positive 2 is positive 4. So often there's a negative and a positive answer when you square root. Of course, because we're square rooting 0 here, the answer is just 0. So we don't need to worry about a plus and a minus, because it's not, that only applies for numbers other than 0. So we end up with x equals 0 as our answer, which means when we look back up here, where does the line cut through or hit the x-axis? Well, it hits it right there where x equals 0, and as we said, y will always equal 0 as well at an x-intercept. So there you have it. That is where it meets it, which can help you in drawing the graph that I've drawn. We'll have more videos on graphing specifically that you can look at. So that's how you deal with that situation. What about this situation where you have more than just an x² term? So even if I just had 3x², you follow the exact same process I just did there. You would just divide off by 3 at some point, but that would still be the same case as that. What about when I add minus 9x? Now I've got 2 terms. I have 2 terms to deal with. Well, again, I'm interested hypothetically, so not necessarily in this question, but I like to visualize it. I'm interested in finding the x-intercepts on this graph, because then it will help me graph this parabola, this quadratic, right? Remember, the shape is a parabola. Now, how do I do that? I have to make y equals 0. That's always the first step. Once you make y equals 0, you're now looking at points that will hit the x-axis, which means you're going to find an x-intercept or x-intercepts. There might be 2. In this case, there was only 1 because it just touched it once, then went back up. But if that curve went through it, it would have hit it twice. So what do we do here when you have an x² term and an x term? Okay, what you do here is you factorize out the common factors in both of these. And we know there's a common factor because they both have x. They also, in this case, both have 3. They both at least have 3 as a factor. Now, even if we didn't have 3 and 9, we would still just factorize the x out. Okay, so we factorize out the common factor. So that's the key step, which is 3x. Both of the terms have 3x as a factor. Then we have to put in brackets the numbers that would take us back to this original. So 3x times what would give us 3x²? Well, x. 3x times what would give us negative 9x? Don't forget about the negative. Well, 3x times negative 3 would take us back to the original. So remember, this line is not meant to be a different value to this line. It's just a way of expressing it in factorized form, because then it makes it easier to solve. So remember, we're solving for the x-intercepts. When we draw our line, I want to see where the curve goes through the x-axis. And now we can solve it by doing this. We need to make sure the left side is equal to the right side. So we're interested in what values of x. What values of x would make the left-hand side, which is 0, equal the right-hand side? Well, we need to focus on the two parts separately. So let's start with 3x, because we know that the 3x at the front is multiplying this bracket. So we'll deal with the bracket separately, and we'll deal with the part at the front separately. So let's first of all deal with the 3x. Think about 3x. If we make 3x equals 0, then does it matter what's inside the bracket? Because if 3x made to be 0 was multiplying any number in the bracket, the whole side would be 0, because 0 times anything equals 0. And we want it to equal 0 because that's what the left side equals. And we want the left side to equal the right side because that's how you solve an equation. So, how do we make 3x equal 0? Well, we can just divide this off by 3, because 3x is 3 times x, and we want to get x by itself. So to get x by itself, we do the opposite of what is happening to x. And 3 times x is what's happening, so we divide by 3. And then the golden rule says what you do to one side, you do to the other. So I divide 0 by 3. Now what does this work out to be? This will just give us, because 3 divides off by 3, they just become 1 and 1. So we don't need to write those in. We just get x equals 0, because 0 divided by 3 is 0, because you had nothing in the first place. Nothing chopped up 3 times is still nothing. So we have x equals 0 as a solution. And then the other solution we need to look at is the bracket, because if we make the bracket equal 0, x minus 3, then it doesn't matter what 3x on the outside here is. We could have 1,000. We could have 3 times 1,000, which would give 3,000. But if that number's multiplying by 0 in the brackets, then all of it becomes 0. So how could we make x minus 3 equal 0? So I'm grabbing the bracket here. I want to make that equal 0. Well, what's stopping x from being by itself in order for us to solve this? Well, the minus 3 is there. It's in the way. How do I get rid of minus 3? I have to do the opposite. I plus 3, because minus 3 plus 3 is 0. So that clears that out of the way. But I can't just do that. What I do to one side, I have to do to the other side. So I plus 3 to the other side. And then that gives me x equals 3. I get x equals positive 3. So take a look at this. If I substitute that into this bracket, I would get 3, because I have to put 3 now where the x is. 3 minus 3, which is 0. So even though I get 3 times 3 here, because I also have to make this x3, which is 9, it would be 9 times 0. Okay, so think about that. You would have 3 times 3, bracket, 3 minus 3. This is if I substituted in 3 wherever the x is, which is what this is all about. You would end up with 9 times 0. And again, it doesn't matter that there's a 9 there. 9 times 0 equals 0, and that's what the left-hand side equals, therefore it's solved. So therefore, x equals 0 is a solution, and x equals 3 is a solution. So we can put a dot here at 0 and put a dot here at 3, and now we know that if we graph this curve, it's going to look something like this. And you can see the distinction. This one just hit 0 once and went straight back up because it only had one intercept. This one had 2 intercepts. The answers to this was 0 and 3. Okay, and you can see why that was, because we had these 2 parts. So we have 0 and 3, and I know that the U shape has to be going up. It's the upwards U shape. Why? Because 3 is positive. Because remember, it's all about the number that's before the x squared term. So because there's a positive 3 before the x squared term, it is shaped upwards. Whereas if it was negative 3x squared, if we had that negative out the front, it would be downwards. Okay, so here I know it's upwards. I'm not trying to show you every single step to graph in this particular video. As I said, watch our other videos for that. But here I know roughly that it's upward facing. I know it goes through 0 and 3. And a handy thing to know is that the parabola here, the quadratic, when graphed, will always be symmetrical. Okay, so what you do is you get the halfway point between 0 and 3, and it's going to look symmetrical on both sides. So I know between 0 and 3 is roughly 1.5. So that's how I knew to send the parabola back up after I got about halfway down. Hopefully that makes sense. That's how you solve that type of quadratic. Okay, let's have a look at the next type of quadratic. Have a look here. The next type of quadratic is y equals 2x squared minus 32. So, y equals 2x squared minus 32. What's different about this particular one? Well, see how in the other example we had two terms as well? But the second term was an x term. Whereas this time, we still have the x squared term, because every quadratic will have an x squared term at least. But now we just have a number or a constant. We have a constant, a number without an x attached to it on the outside. Okay? So how do you factorize this type of question? Well, first step, again, we want to make y equals 0 in this hypothetical because that's how you would find an x-intercept. So if you get a question that already gives you 0, just pretend that you were finding the x-intercept for an equation or a function that had y where the 0 was, okay? So sometimes you'll just be given a question that says 0 equals 2x squared minus 32. It won't even mention that there was a y, so you're not even worried about graphing. But you can imagine that there used to be a y if it helps you. It helps me understand it, certainly. So 0 equals 2x squared minus 32. How do I factorize this? Well, because again, there's only two terms, what I'll first do is actually see if there's any common factor. And there is. Even though they both don't have an x, they both have 2 as a factor. 2 goes into 2 and 2 goes into 32. So again, I factorize out the front, the common 2, and then I work out what needs to go in the brackets by reversing what I just did. So 2 times what gives me 2x squared? X squared. And 2 times what gives me negative 32 minus 16. Okay, so again, these are the same values. This is just factorized. This is expanded. Next step is to actually divide off the 2. Because the 2 doesn't have an x next to it before we get to the brackets, I know there's an x in the brackets, but it's just 2 on the outside. You can actually divide off when solving by the 2. You never divide off by an x, but you can divide off by a number. So 0 divided by 2. Again, I've done it to both sides because 2 is times in the brackets. But 0 divided by 2 is 0 equals... Now, 2 divided by 2 is just 1 over 1, so we don't need to write those ones again. We can just write it like this. So 0 equals x squared minus 16. Now, there's 2 ways to solve this. I want to show you the 2 ways. Let's do the first way. Some of you might prefer this. We are basically going to... I'll rewrite it here. We are going to move... Again, I want to get x by itself. What's the whole point of this? Let's just remember the purpose. We want to find out what value of x, what number should I put where the x is, so that if I squared that number and then took 16 away, this side would equal this side. And I know that that side's 0. So I need to make this side equal 0 by putting the right number where the x is. Now, what I can do here to solve it is just try and get x by itself on one side, and then it will reveal the answer. And the way you do that, the way you solve an equation that way, is to actually do the opposite of what's happening to the x. And we start the furthest away that we can from the x, and then we move in. And what I mean by that is, I want to get rid of the squared, but I also want to get rid of the minus 16. Because the minus 16 is more separate than the squared to the x, I'm going to deal with the 16 first. Now, if it says minus 16, I'm going to plus 16. And I've got to do that to both sides to make it even. Okay, what you do to one side, you do to the other, the golden rule. 16 equals x squared. That's what I'm left with. Always a good idea to keep your equal signs aligned, by the way, whenever you're doing any working in maths. It'll make things a lot easier to follow. Okay, so we've got 16 equals x squared. What do I then do? Well, I want to get x by itself. So how do I get x by itself? I need to get rid of the squared. What's the opposite of squared? Square root. Okay, so I square root both sides. What you do to one side, which I had to do to this side to get rid of the squared, because squared and square roots cancel each other out. That's why I'm doing that. But then what I do to that side, I have to do to the other side because of the golden rule. So remember, when you square root a number out here, I have to do plus and minus. I'll explain that again in a second. What's the square root of 16? 4. and I have to put plus minus there, otherwise you'll get it wrong. It's not just positive 4, it's also negative 4. Because think about it, what's negative 4 times negative 4? 16, because a negative times a negative is a positive. And 4 times 4 is 16. Okay, so remember, 4 times 4 equals 16, but negative 4 times negative 4, so I'll just do this as a wall, negative also equals 16. So that's why we have both of those as a possible solution to the square root of 16. Because you can get to 16 two ways. You could square 4 or you could square negative 4. Okay, so we have two solutions. We have x equals 4 or negative 4. So what does that mean for my graph? And you should always make your answer clear, typically by circling it. What does that mean for my graph? It means that if I was to graph y equals 2x squared minus 32, which is this up here, if I was to graph that, I know that the x-intercepts are negative 4 and 4. And again, is it going to be an upward facing U-shape? Is it a normal U-shape? Or is it an upside down U-shape in terms of the parabola? Well, remember, is the number before the x squared positive or negative? It is positive. It's positive 2, right? There's always an invisible positive unless you see a negative. So that means it is upward facing, so I can draw this graph in. And I also know, by the way, just to show you another step here that you would do if you were graphing, is I know the y-intercept is going to be the number, the constant, by itself on the outside. Because if I substituted 0 for where x is, you would get 2 times 0 squared, which is all 0, negative 32. So the y-intercept is minus 32. I can just add this extra little step in for those of you who understand that. Again, I'll do that in another video in more detail. But basically, I know 3 points now. I know the two x-intercepts, which I just got through this method. And I also know, just by looking at this, that if you can see a number by itself on the outside that is a constant, so there's no x next to it, that is the y-intercept. Okay, so I can get my graph like that. Cool, so I haven't quite done them even, but they would both keep going forever on both sides. Hopefully you can see the point that I can now know for sure that these 2 points that I've filled in there on the x-axis are the x-intercepts because of doing it, and hopefully you can see how you factorize that particular type of quadratic. Okay, shall we move to the next one? So the next one was y equals, I'm just going to write it in here, y equals x squared minus 9x plus 20. Now why is this different? Now we're entering a new world, a new world of trinomials. So you'll see that the last two here have their own unique method. They are trinomials, which means they have all 3 possible terms. They have an x squared term, they have an x term, and they have the constant. Notice none of the others had all 3. They either had a combination of the 2, always with an x squared because it's a quadratic, or they just had the x squared by itself. So how do you do these? We use a method called PSF to factorize. I'm going to show you that in a second, and I go in more detail in another video, and 2 other videos that you should watch about how to factorize a monic quadratic trinomial and a non-monic. And a monic quadratic is where the number before the x squared is simply 1, and a non-monic is where the number before the x squared is something other than 1. Okay, so there's 2 different ways of using the method I'm going to show you now, and I can show you for each of them, and I can show you both methods while solving these 2 equations when I make the y equal to 0. Okay, so we're looking at y equals x squared minus 9x plus 20. Because it is a monic, I can use the easy version of PSF. It's a monic because the number before the x squared is 1. Okay, there's a 1 before the x squared, which is invisible, so therefore it's a monic. We're going to make y equal 0 because we're going to pretend that we're finding x-intercepts, whether the question wants you to do that or not. Certainly, if you've got to graph this equation, then you need to do this. You would substitute y for 0. That's going to tell you where those x-intercepts are on the graph. like where -4 and 4 were here. And we're going to do that, and then we're going to rewrite this right side. And now our job is to solve. We need to solve, so we need to make this side 0 equal this side. The way to actually answer that is to say, what value of x, what number could we put where the x is in this right side, in this expression, so that all of this, when you do what it says, when you square the number, then -9 times that number, then add 20, all of it equals 0. How can we find that? Well, we can't factorize directly here. The first thing I look at is whether there are any common factors between the three terms, and there are not. Sometimes you may get a common factor, such as 2, if 2 went into all of these numbers, but it doesn't in this case. So instead what I do is I go straight into this method called PSF, which you'll find in some other videos we have. And what you do is you say, look, I need to find two numbers, because ultimately I want to rewrite this with brackets. As you can see, putting things into brackets makes things a lot easier. And what I'm going to do is I'm going to say, look, I know that the first term, x squared, if I was to multiply two numbers together, I know that they would have to be x and x. Because, again, if you were expanding these brackets, if you were undoing the process here, you would get x times x equals x squared. So we know that that's x and x. The question is, what two numbers go here, including positives and negatives? The way you find these two numbers in this factorized version of this expression, so this is just a factorized version, okay? We need to do this. We need to find the product, P means product, of the two factors, which is always going to correspond to the constant, the number at the end, including the sign. So always make sure you've got the expression ordered with the x squared term first, then the x, then the number. So we need the product of these two numbers to be 20. We need the sum, S means sum. We need the sum of those two numbers to be the number before the x, which is -9. That is the coefficient, that is the x coefficient. That means the number, including the sign, before the x term, right, before the x here, so -9. And now what we do to find the two numbers that are going to go into these brackets, we ask ourselves firstly, so don't do this out of order, firstly, what two numbers multiply together to give 20? And then secondly, once I think about those possible combinations, which one of those combinations also add together, which could mean subtract if there's negatives, to give -9? So what two numbers, first of all, multiply to 20? Well, you could probably think 2 and 10, 4 and 5. Okay, any others? Maybe 20 and 1, 1 and 20. Okay, so we've got those possible combinations. We've also got the negative versions of those combinations, if you think about it. -2 times -10 would be +20. -4 and -5 would be +20. And -1 and -20 would be +20. Now the question is, out of all of those 6 combinations, and you'll get quicker and quicker at doing this yourself with practice where you won't have to write them out, which two add or subtract to -9? So let's plus them together. 2 plus 10 is 12. That's not -9. 4 plus 5 is 9. That's +9, but not -9. 1 plus 20 is 21. That's not -9. -2 plus -10. So you still add them, but it will become a plus because -2 plus minus becomes a minus. So -2 minus 10 becomes -12. Now look at this one. -4 plus -5. And again, plus and minus make a minus, so it really becomes -4 minus 5 is -9. So there we go, bingo. So -4 and -5 are the factors that multiply to 20, which is given by this n term, and add to -9, which is the middle term. So we just fill those in. They're not your answers directly, but they are the numbers that would go into the brackets. So now think about these brackets as just another way of writing this original. It's just the factorized version, and you use PSF to get there. Okay, so how do we solve it from here? Well, again, we want to make this right-hand side equal 0. And another way of breaking that down now is we want to make either of these brackets equal 0. Because if one bracket as a whole equals 0, then it doesn't matter what's in the other bracket, because it will be the other bracket's number times 0, which is always going to be 0. So we look at each bracket and we say, look, how could we make this bracket, x minus 4, be 0? What number would we have to put where x is? And it's always going to be the opposite of the thing that's next to it. So what's next to x? Minus 4. So the solution is x equals plus 4. That's an answer, because if we do 4 minus 4, you're going to get that bracket equaling 0. And then even though you're going to substitute 4 for that x, so that's going to be 4 minus 5, which equals minus 1. So even though that's not 0, 0 times minus 1, it does equal 0. And that's what we wanted to do, because that's the left-hand side. So that's how you solve it. So x equals plus 4 is an answer. And then let's have a look at the other bracket. What's the opposite of minus 5? Plus 5, because 5 minus 5 would equal 0, which would then multiply this bracket to make the whole side equal 0, which would solve the equation as well. So we have our two answers as plus 4. I don't need to write the plus because it's invisible. You only have to write minuses. And 5. So if I wanted to graph this, then I can simply put in now 4 is here, 5 is here, roughly. Not being too exact here, I'm just showing you an example. And again, I also know that the y-intercept, see if you can see what the y-intercept would be. Well, it's not x squared minus 9x plus 20. It's always the part at the end, the constant, that's by itself. So plus 20, let's say, is here. And again, that proves that it is going to be concave up. It is concave up, like here. See, that's called concave up. Whereas the other one's concave down. We know it's going to be concave up because the number before x squared here is an invisible positive 1. Okay, so unless it's negative, it is going to be like this. Now, it's not a perfect graph, but roughly that's what this graph is going to look like. That's what that quadratic function would be graphed as. Using those two x-intercepts and then getting the y-intercept, it becomes pretty easy to graph a quadratic. Okay, last one we're up to. What's our number 5 here? We are going to graph a non-monic quadratic trinomial. So let me do that using a different version of PSF. So again, I will write in the equation again. Now again, we're pretending we want to find the x-intercepts. Sometimes you will want to find the x-intercepts. So I'll write this back in. Now we want to use PSF. Again, ultimately, we want to be able to rewrite this expression using brackets so that it's easy to see what the value of x has to be in each case to make the whole thing equal 0. Hopefully you got that from the last example. If we can put this into brackets, it becomes a lot easier to see what x should be, what x may be, to make everything on this side equal 0. Okay, so let's have a look here. We want to use PSF. It's a slightly different version of PSF though. To get the product in this case, because it's a number other than 1 before the x squared, you've got to be very careful. If it's any other number than positive 1, what you do is you have to multiply the number at the front of the x squared, which means it's different to the other example, and you multiply it by that n number. So instead of p being 4, like it would have in the last case, it's 2 times 4. So it's 8, positive 8. The middle term, however, stays exactly the same. And then what we do from here is we work out which two numbers would first of all, don't get confused by the sum, would first of all multiply to 8 and then also add or subtract in effect to minus 9. Now I know that two numbers that multiply to 8 are 8 and 1, but also negative 1 and negative 8. There's also 2 and 4, and negative 2 and negative 4. But which one of these combinations would add to negative 9? It's going to be negative 1 plus minus 8, because the plus and the minus there would just create a minus. It's negative 1 minus 8, which equals minus 9. So bingo, there they are our combination. But unlike the other example, unlike the monic quadratic, this is a non-monic. We don't put the numbers straight into here. Okay, and we also don't write x and x because look, have a look. It's not x squared. X times x is x squared. This is 2x squared. So that's why you don't write anything in advance here. What we do is we take these two factors, okay, we take those two factors and we use them to rewrite the original equation. Okay, so you rewrite the original equation where the middle term here, see how it was negative 9x? So that's what this non-monic method's all about. It's about rewriting the middle term using these two numbers, because we can write negative x, which is negative 1x, it's the same thing, minus 8x plus 4. So notice how I've rewritten that middle term in a seemingly more complicated way, but there's a reason for doing it. But it's the same thing. Minus 1x minus 8x is the same as minus 9x because they're like terms. The reason I chose to rewrite them in this funny way is because of the factors here. That's what it told me to rewrite it as. And then what I can do after that is actually factorize in pairs now, so I can split up. See how there's 4 terms instead of 3? I wanted to do that because now I want to split up this expression into 2 halves and factorize both sides separately. Have a look at what happens. So if I just look at the first 2 terms, that's the first thing you do, it's 2x squared minus 1x. What's the common factor? X. So I get x, and then I have to see what I would have to multiply that by to get back to the original. So x times 2x would get me back to 2x squared, and then x times minus 1 would get me back to minus 1x. Now we do the other side. So I only look at minus 8x plus 4. So it's called factorizing or grouping in pairs to factorize, okay? So minus 8x plus 4, what's the common factor? 4, right? I'll take out negative 4 because this one has a negative. So even though they don't both have a negative, because the front one has a negative, I'll take out the negative. And then we'll say negative 4 times what equals negative 8x? Well, it's 2x. And then negative 4 times what equals positive 4? Well, it's negative 1. Now, the reason it's negative 1 is because a negative and a negative gives the positive. So you can't put a positive there even though there's a positive there. Because we took the negative out, you have to correct now by making it a negative times a negative to get back to the positive. Now, have a look at what happens. This magical thing will happen where the brackets end up being exactly the same. And that will always happen if you've done this method correctly. Which leads us to the last step, where what you do now is you grab, because these brackets are exactly the same, you can actually factorize the bracket out by itself. So you end up with 2x minus 1 in one bracket, and then what goes in the other bracket are just the 2 parts or the 2 numbers that were on the outside. So you get 2x, or sorry, not 2x, you get x minus 4, because there was an x in front of that bracket and there was a minus 4 in front of that bracket, so they both go in the bracket next to it. Alright, so that actually leaves you with the answer. The answer is 2x minus 1, x minus 4. And now, using these brackets here, we can solve to find out what value of x will make this whole side equal 0 so that we've solved the equation. Okay, well, let's start with this bracket over here. X minus 4, we need to make all of that equal 0. Well, x must be the opposite of minus 4, so plus 4. So x equals 4 is one answer. Because if we made x 4, it would be 4 minus 4, which equals 0, which would then multiply anything in this bracket to make the whole thing 0, so that would satisfy the equation. The other thing you can do is, which you'll have to do, rather, here, is not simply make x equal positive 1. Even though there's a minus 1 there, you don't make it equal positive 1 because there's another number in front of the x. So this is an exception to the normal rule where you simply do the opposite. So it was minus 4, we made that positive 4. This one's minus 1, we don't straight away just make this 1. What we do is we make the 2x, we make the whole thing equal 1 and then solve it. So instead of making just x equal 4 or x equal 1, we make 2x equal 1, and then we'll solve for x here. So it's 2 times x. What's the opposite of times? Divide. So we divide to get rid of the 2, because you always do the opposite. 2x divided by 2 leaves 1 over 1. And the golden rule says what you do to one side, you have to do to the other. So we are left with x equals a half. Okay, great. So now we have our 2 solutions. We know that if we substitute a half there, the whole bracket will equal 0. And then it doesn't matter what's in this other bracket, because 0 times anything is 0, which would equal the other side. So we'd solve the equation. Okay, great. So if we tried to graph this particular equation. So if you got asked in an exam to graph this, you would now know that as part of that graphing process, you should make 0 equal y to help you find the x-intercepts, because down here we now know the x-intercepts, and we also know what the y-intercept is, because the y-intercept is always the number by itself without an x, which is plus 4, so this bit is the y-intercept. So when I want to go and graph this, we always do x, y, and 0 when we do our graphs. When I want to graph this, I already know the key points. I know the y-intercept is 4, and I'll put that in a second. And I know the x-intercepts are a half and 4, both on the positive side. So I'll make this a half, right, which is 0.5. And I'll make this 4. So we know there are our x-intercepts because we just figured that out doing that factorization method. And we also know that the y-intercept is 4. Great. So what we do is, because we have these 3 points, and we know that it's a U-shaped parabola, right, as we've already talked about, every quadratic will have that parabola shape, parabolic shape, and we know that it's concave up because the number in front of the x squared is positive. I know that it is going to loop around like this. And there you go. Here's how you graph this type of parabola or quadratic. So it's going to be something like that. Okay, so that's how you do all of those main 5 types of quadratics. I hope that helps. If you enjoyed the video, please like, make sure you subscribe to the channel and hit the bell, and I'll see you in the next video.